Linear equations in 3 dimensions, section 3.5. Up to this point, we've been talking about the 2 dimensions as in 2D planes, x and y. Here and tomorrow, we're going to talk about linear equations in 3 dimensions. Now we're talking about 3D space. So getting out of 2D plane into 3D space now. Vocabulary. Again, as I said, we're going to talk about coordinate space. Coordinate space is now adding a third axis called the z-axis. So XY plane, now we're going to talk about XYZ coordinate space. So to the coordinate, or so the XY coordinate plane. Instead of ordered pairs now, we're actually going to talk about ordered triples. Now ordered triples is very similar. Why? Because it just goes alphabetical order. X, then Y, then Z. Yes, sir.
I want like down to like slide 6 or 5 or something. It's like X is like positive like that.
We'll talk about that. Thanks, Jack. All right. Next one here. Here's an example of what we're going to be doing today in the coordinate space. Now, I do have a better diagram of this one later. But here's the coordinate space, x, y, z. And again, when I look to graph, I'm going to graph the point 3, 2, 4. We're going to talk about using descriptions. I'll have another slide here later. But we're going to go 3 units forward, 2 units to the right, and then 4 units up. And as you see, they go forward, right, up. Forward, right, up. Okay, that's how you would graph that coordinate. It kind of goes through the different phases of that. But it's a movement in the coordinate space. And as I said, we are going to talk about this. Here is the 3D coordinate space. Now this is what is new, and this is what you need to recognize. The x-axis, okay, it's the diagonal axis there. Really, you got to think of that axis as coming out at you. So you got to think of this axis, again, it's a 3D space on a 2D piece of paper. So you got to think of that x-axis as a line coming out of the wall straight at you. Okay, this line is 3D space. My y-axis is still going to be left and right. My z-axis goes up and down. Again, 3D space. So the x-axis is coming at you. Another way to think about it is the corner of the room here. Okay, if you think about the creases down here, my x-axis would be running here, going up or forward, backward. My y-axis would be running down here. Got it. And then the corner in the room would be my z-axis going up and down. So I have my x, I have my y, and I have my z. The 3 different axes that form my coordinate space. All right, and again, notice where the positives and negatives are. The only mistake students typically make on something like this is they forget that this is the x-axis now. Okay? And again, we're thinking about that because it's 3-dimensional. That does not mean it's going out diagonal. We just showed as a diagonal. It's really coming out straight at you. So when I think of this graphing, I think about going forward or backward. So x-axis is going forward, backward. Forward being positive, backward being negative. So forward, backward. When I have my y-axis, I go left or right. Left negative, right positive. And when I have my z-axis, I go up or down. Up positive, down negative. All right, so when we describe a point like we'll do later, we're going to talk about going forward or backward, left or right, and then up or down. So for example, if I give you the point 1, -2, 3. Okay, 1, -2, 3. I would describe that point as going forward 1, left 2, and then up 3. And that's how you would describe where that point is located. Forward 1, left 2, up 3. Okay, that's how you would describe where that point would be located. Here in the next slide, we're going to talk about where we would actually graph that point. So let's work on graphing these. I want to graph each point in the coordinate space. Now remember, ordered triple is in the form x, y, z. So I have x, then y, then z. Again, biggest part is recognizing this is my x-axis. And I have to imagine that as coming out of the wall. Okay, you got to use the imagination in the 3D space. It's coming out at you. So the point 3, 0, 0. I'm going to go forward 3. Now I like to just use the creases here as my coordinates just to make it easy on yourself. So that's like my tick marks on my x-axis just to make it easy there, so you can see it. But 3, 0, 0, I'm going to go forward 3 spaces. So 3 coordinates, and A is right there. There's coordinate A. It's forward, I didn't go left or right, and I didn't go up or down. That is on the x-axis. Alright, so that one's pretty easy. The next one now it gets a little more tougher. B, -1, 1, 2. So I'm going to go back 1, right 1, up 2. B is actually located right there. Now I'm going to explain that again with the highlighter. I'm going to go back 1, right 1, up 2. And that's how I get to B. Back 1, right 1, up 2. Okay? Take a couple seconds to see if you can graph the other 5 points on this coordinate space. Let's go through some more here. So letter C. If you watch, letter C, it is forward 2, left 1, up 4. So I'm going to go forward 2, left 1, up 4. There is letter C. Does everybody see how I do that? It's forward or backward, then it's left or right, and then it's up or down. So C was right there. D. Tell me which way I'm going to go first on letter D, Tiana. Forward or backward? Back 2. Left or right, Kelly? Right 1. Up or down, Jack? 1 point D.
Down.
Oh.
Down 4. Boom. There is point D right there. Again, forward or backward, then left or right, up or down. Again, you got to think. The hardest part about this is understanding that we're on a 2D paper, and we have to use our 3D visual sense. Okay, it's a little different. Letter E, 0, 0, 2. Am I going to go forward or backward at all, Marisol? Left or right at all? I'm just going to go up 2. Letter E is right there. Letter F, 0, -3, 0. Which way am I going to go, Isabels? Huh? Stay first and then go where? Left how many? 3? And then go up or down at all? F is located right there.
Do the graphs always have to be the same amount right and left as they are up and down for that line to fit?
No, not really. We just can't do it that way. This will show it easier. Makes it easier. Now, what's unique about G? Has anybody graphed G yet?
Yes. Yeah.
Where's G actually look like it's at?
Same spot as it started.
It actually looks like it's like the exact same spot. If you look at -1, -1, -1. I'm going to go back 1, left 1, down 1. And if you look at that, G actually comes out to be right there. Now, is it really there? No. But on our 2D paper, that's where it looks to be. Okay, use our 3D space to understand where it's at. Okay. Do you want to try a couple more problems, or you think you got this? You got this now? Good. All right, next part here. We're going to talk about finding the intercepts to graph. Now, the intercepts are just like if you would find the intercepts of an XY coordinate, or on a coordinate plane. So, for example, if I were to give you the problem 2x minus 4y equals 12. So 2x minus 4y equals 12. What is my x-intercept in that problem, Kelly? X-intercept is what, Colton? X-intercept, Colton? 6? Because remember, to find the x-intercept, you just cover up the y and solve. So the x-intercept is 6. What's my y-intercept then, Autumn? -3. So that's old. We've been able to do x and y intercepts. The new part today is now it's going to add the z-intercept.
I see Z for you.
So here is 3z equals 12. What's my z-intercept, Nolan?
4.
Nice job, sir. So what I'm going to do is I'm going to plot the intercepts. So there's 6, -3, and 4. And then I sketch what is my plane. Now understand it, it's a plane, it's not a line, because it's in 3D space. It cuts up what would be a plane now. So I sketch my plane and I kind of shade in where the area of that plane would be. Okay, so the triangle represents the plane there. Alright, so number 1 here. I want to sketch the graph of 2x plus 2y plus 4z equals 8. Now, the first thing I need to do is find the intercepts. So I want to find the x-intercept, the y-intercept, and the z-intercept. Let's see here. Jersey, what is my x-intercept? What? Tiana, what's the x-intercept? Thank you. To find the x-intercept, I just cover up the y and z. Kind of the shortcut way, solve for x. So the x-intercept is 4, so I'm going to plot 4 right there on my x-axis. X-intercept. What is my y-intercept, Shanks? 4? So I look at my y-axis. There's my y-intercept. What about my z-intercept, Jesse? 2, good catch. So now I have that. Now I'm going to connect my dots. And I get my coordinate, or I get my plane right there. Again, the first thing you do is find the intercepts. And what you do, kind of make a triangular region. That's where this plane intersects the 3 axes. So the toughest thing there is finding the intercepts. Alright, try number 2 on your own here. Find the x, the y, and the z intercepts. Alright, so the x-intercept. What is my x-intercept here, Sequoia? What did you say it was? 3, thank you. X-intercept's 3, right there. Y-intercept, Marisol? 3. And my z-intercept, Nolan? So there's my intercepts. Now I connect my dots. Shade it in. There is my coordinate, or sorry, there's my plane that intersects my axes. Nice job. Try one more. Last one here. Try this one. What is the x-intercept, Jersey?
4.
It's not 4. It's actually -4. X-intercept is -4. What's the y-intercept, Destiny?
2.
Close.
-2.
-2. What's the z-intercept, Nolan?
4.
Connect my dots now. Shade my plane. There is the coordinate plane. And here is your assignment.